Hi, it's Mrs. V here, and today we are going to talk about the sign convention for delta H. So let's get that whiteboard on and get on with that. One of the strange things I found about thermochemistry when I was just a young student of chemistry was the fact that exothermic reactions had negative delta H values. I always thought that was very strange because I always thought something that made things get hot should not be negative. But in any case, the sign convention for delta H, and we say it's a convention because it doesn't have any meaning other than it just tells us whether it's exo or endothermic. The sign convention is that exothermic reactions have negative delta H's and endothermic reactions have positive delta H's. Let's explore how that is worked out. Well, you can think about it, I guess, from a point of view of energy loss. So in an exothermic reaction, the substances involved that are reacting lose energy. So that's one way you can think about the negative, but the main reason is that delta H is always calculated by products minus reactants. And if we come over to our energy profile diagram here, don't worry about the fact that all of a sudden we're saying potential energy instead of energy. It doesn't really matter. If we look here, we've got the sum of the enthalpies of the reactants. So sum H reactants. And then if we're to mark the level of the products on this axis as well, this would be the sum of the enthalpy of the products. Now, because we're on an axis that starts at 0 and increases, what we have is that the reactants here, the sum of enthalpy of reactants is the bigger number, and the sum of enthalpy of the products is the small number because it's further down the axis. So when we come to do our delta H calculation, our delta H is the products, sum of the enthalpy of the products, minus the sum, I might do that one again, the sum of the enthalpy of the reactants. Then what we're going to be seeing here is the products was the smaller number. So we've got a small number here, and we're going to subtract a big number. And if you have a small number and you take away a big number, then you're going to end up with a negative answer. And that, because of the convention, it's just a convention. Once upon a time, somebody decided that's how we were going to calculate delta H, and forevermore, that's how we've done it. Because of that convention, you always get delta H being negative for exothermic. And of course, the opposite is true for an endothermic reaction. So for an endothermic reaction, remember we're still going to do products minus reactants. But come over to the energy profile, and we see this is the sum of the enthalpy of the reactants here. But this time, if we come from the products, across to the graph, this is the sum of the enthalpy of the products. So now, when we do our delta H calculation, which is the sum of the enthalpy of the products minus the sum of the enthalpy of the reactants. We're going to see that now, over here, the reactants is the small number, and the products is the big number. So now we're going to have the big number, and we're going to take away the small number. And of course, if you have a big number take a small number, you get a positive answer. And that is where the sign convention comes from. So summarising, exothermic reactions, delta H is negative. And endothermic reactions, delta H is positive. Now when we see equations that have delta H values written next to them, we can immediately tell that the reaction is exothermic or endothermic just looking at the sign of delta H. So in our first equation here, iron reacting with oxygen to make iron oxide, we have a negative value. So we know that this is exothermic. And in our second example, we see that delta H is positive. So that's endothermic. You might have even recognised this second equation as the equation for photosynthesis. And of course, we know that photosynthesis is a reaction that takes in energy because it uses energy from sunlight. Anyway, that's all we've got for you today. I will see you in the next video, and we will be using these delta H values a lot more. I'll see you next time.